Alright, this is our first lecture on 7.1, adding and subtracting polynomial expressions and functions. We're going to discuss quite a few different definitions, those of terms, monomials, polynomials, degrees, coefficients, like terms, polynomial functions, quadratic functions, parabolas, vertexes, and cubic functions. We're going to learn how to add and subtract polynomials. We're going to evaluate polynomial functions. We're going to recognize some typical graphs of quadratic and cubic functions. We're going to find sum of functions and differences of functions, and we're going to use some functions and differences to describe some real-world situations. I will probably leave that to Lehman's text alone. Our first discussion here is of like terms. So first of all, a like term is a number, a variable, a product of a number and a variable, or a variable raised to a power. So our first example is the number 5. That is a term. 5x is also a term, xy is another term, and x squared is another example of a term. Like terms are terms that have the exact same variable components. So we're going to take a look at a through f here and decide whether they're like terms or not. And if they're not, why not? So first of all, we're looking at 7x and 10x squared. Well, we see that the exponent is to the first power here and the exponent is to the second power here. So these are not like terms because of those differing exponents. The next one, part B, we have negative 15z and a 23z. We see that the z's are both to the exact same power, so these are like terms. And again, the numeric coefficient, the numbers out here, remember, that are multiplied by the variable, those have nothing to do with whether they are like terms or not. Our next one, we have t to the first power and t to the third power. Well, the first power and the third power are different. Even though the t's are the same, their powers are different, so these are not like terms. The next one here, 5 and 5w, we want to make sure that we're not making the mistake of focusing on the numeric coefficient. So just because these 5's are the same does not mean that they are like terms. These are different. They are not like terms because this one has a w and this one has no w. The next one, xy and 6xy, these are like terms because they both have just an x to the first power and just a y to the first power. Again, no focusing on the numbers because they're different doesn't mean that they are different terms. These are, again, like terms. And our last one here, we have an x to the second power. Here we also have an x to the second power. However, our y is to the first and our y is to the second over here. So these are not like terms because all of the exponents are not exactly alike. All right, moving on to some more definitions. First of all, we have to define a monomial. A monomial is a polynomial that just has one term. And a polynomial is a sum of two or more terms that can be described as a times x to the nth power. And now we want to talk about some things called degrees of terms and degrees of polynomials that will help us in our adding and subtracting in just a little bit. So first of all, let's take a look at these examples of polynomials here. The following are all polynomials: a squared plus 3a plus 5, that is a polynomial, and b here, 3b plus 4b cubed minus 2b squared minus 6, that is a polynomial as well. 10x squared is a polynomial. It's a monomial. It's one of our special ones. And the a here, we also have a special name for that, by the way. It's called a trinomial, a 3-termed. That comes up in the second section of our chapter. And the last one down here is also a polynomial. This one's kind of a special polynomial because it has something in parentheses here. And that would need to be expanded, and we'll learn about expanding later as well, but it still is a polynomial because it's something raised to the second power minus a constant. There's two terms in that. That's another special polynomial called a binomial. Now, our next example, example 4, what we're going to be looking at here is the degree of the term. And in finding the degree of the term, what we're doing is we're looking at the sum of the exponents in a term. So I'm going to leave this example for our next video, and that's where we'll start.